Circles. All right, when we talk about circles, we know that a circle is a set of points that are all equidistant from a center point. We like to label that center point as HK, which is how we're going to label important points all throughout this chapter. With parabolas, we labeled the vertex HK. Circles, we're going to label the center HK. And that's the set of points equidistant from that center point, and we refer to that distance as the radius, r. So, nothing new there. We're all very comfortable with circles, or at least that's the assumption I'm making. So here, just a little bit more formal look, saying exactly what I just said. Circle is the set of all points in a plane that are a distance r from a given point, the center of the circle. The distance r is the radius of the circle. The use of distance in these definitions makes the distance formula, yada, yada, yada. So if you look at the distance formula, what they have there, down here they're illustrating how the distance formula gives us the equation of a circle. The distance between the 2 points is the radius, because we said that a circle is defined as having that same distance all the time, and that distance is the radius. So instead of d, we have r. And it's the distance between 2 points, where one of the points is just an xy point on the circle. So that could be anywhere on the circle. We refer to that point as xy. And the second point in our distance formula is the center, which is hk. So this is always going to be h, this is always going to be k. The xy is the point that's going to change. And if you take this equation and square both sides, you get r squared is x minus h squared plus y minus k squared, which is the standard form of an equation of a circle, which is something you should have seen last year. So when you look at the standard form for the equation of a circle, you can see right off the bat where the center is and what the radius is. Transforming a circle, all they're talking about is you can think about any circle being centered at the origin and then just move it. Okay, where the h and the k, all they're talking about here is the horizontal movement is h and the vertical movement is k. So you can think about any circle being at the origin, and then you can move any circle around to whatever point you would like it to be. Okay, just kind of reinforcing the idea that the h is the x part of the center, the k is the y part of the center. So h would be your transformation horizontally from the origin, k would be your transformation vertically from the origin. So now we get into some fun stuff. What is an equation of a circle with center 3, -5 and a radius of 2? We know that the standard form of the equation of a circle, x minus h squared plus y minus k squared equals r squared. So it's x minus 3 squared plus y plus 5 squared equals 2 squared. Boom. The only thing, when you subtract -5, that's plus 5. So, what is an equation for the translation of x squared plus y squared equals 10 by 2 units right and 5 units down? So, the idea, we have a circle centered at the origin with a radius of what? In the original equation, our radius, so we know the center is the origin, and the radius is the square root of 10, whatever that is. So let's draw that circle. Now the trick when you're trying to draw a circle with the center at the origin, the trick is to draw the circle and then the axes. That makes life much easier. So do your best to draw a circle, and then the xy axes, do your best to put them so that the center of the circle right at the origin. That's much easier than drawing the axes and then trying to draw a circle right around that origin.
True.
It's very true, that's why I said it. But thank you for having my back there. So, this is the circle with equation x squared plus y squared equals 10, where again this distance right here is the square root of 10, whatever unfortunate decimal that ends up being. So we want the equation for that circle shifted 2 units right and 5 units down. What is the equation for that transformation? We know that the center of the circle after the transformation is 2 to the right and 5 units down. Now, just moving it to the right and down does not change our radius. It's going to have the same exact radius. So the equation of that circle is x minus 2 squared plus y plus 5 squared equals r squared, and the square root of 10 squared is just 10.
I'm confused as to how you
Word problem. So step 1 of a word problem is to read the problem. You row a boat from the water's edge to the center of a circular pond located 30 feet north and 80 feet west of your starting point. If the location where you began rowing is the origin, what equation represents the water's edge around the pond? So this is incredibly similar to the problem we just did, in that you start at the origin, they give you some translations. Okay, what's the only thing that's a little bit different? It's that they don't tell us what the radius is. We're going to have to figure out the radius on our own. So we know that we are at a circular pond, like such. We know that we row 30 feet north and 80 feet west of our starting point, and that's where the center is. Which means that we know the center. They tell us to imagine that the starting point was the origin. So the coordinates for that center, 30 feet north and 80 feet west, is negative 80, 30. Negative 80 because if we start at the origin, we go 30 feet north, yeah, and then 80 feet west.
Well, it depends on where you're standing.
So now, what we need to do to get the equation is to find out what the radius is. The nice part is we know the center and we know a point on the circle. 0, 0. The point at which we started on the water's edge. So the general equation, the standard form equation for a circle, x minus h squared plus y minus k squared, is r squared. We know that x and h, or x and y, come from the point on the circle. H and k are the center. So we have 0 plus 80 squared plus 0 minus 30 squared equals r squared. We know that 80 squared is 6,400. We know that 30 squared is 900. That equals r squared. So what do we have? 7,300 is r squared. I hear some of you getting your calculators out. They asked for the equation of the circle, right? And in the equation of the circle, what we need is r squared, isn't it? 7,300 is r squared. You could put in what's the square root of 7,300 if you are just intrinsically motivated to find out what decimal that represents to get the radius. But they didn't ask us for the radius, they asked us for the equation. So our equation is x plus 80 squared plus y minus 30 squared equals 7,300. What are the center and radius of the circle with equation x squared plus y squared plus 2x minus 6y equals 6? Unfortunately, in order to do this, we have to be able to factor down into our standard form equation x minus h squared plus y minus k squared equals r squared, which means we have to complete the square here and here. We have to just complete the square twice. So taking our original problem, we get x squared plus 2x, and then we get y squared minus 6y, and all of that equals 6. So we want to complete the square here and here. So from yesterday, hopefully we remember, these are two relatively easy completing the square problems because the coefficients are 1. And you have to remember in completing the square, the first step, make sure the coefficient of x squared, or y squared in this case, is 1. After that, you take the coefficient of x, divide by 2, and square it. 2 divided by 2 is 1. You square it, so this is plus 1. In the y, right here, take this, divide by 2, and square it, you get plus 9. To keep things balanced is we add 10 over here, right? We added 10.
Yeah.
So on the right side we add 10. So we get x plus 1 squared plus y minus 3 squared equals 16. What is the center? -1, 3. What is the radius? 4. Now we get to graph a circle. Looking at the equation, we can tell that the center is the point 0, 1, and we can tell that the radius is 4.
Yeah.
So, center at 0, 1, we just need to go 4 spaces in every single direction, up, down, left, right. So, up 4, left 4, right 4, down 4, and then play a little connect the dots.
Love that game.
Hand-drawn graph, looks terrible, but that's all right. So when you're graphing a circle, you want to locate the center. You want to locate the 4 points, up, down, left, right, and then do your best to draw something that most closely resembles a circle.
Just